Look around you. Take a moment to truly observe the room you are sitting in. The walls, the chair beneath you, the screen glowing before your eyes, even the hand you use to touch it. Your senses tell you a very specific, comforting lie. That the universe is solid, that it is crowded, and that it is substantial. We are evolved to perceive matter. We are creatures of substance, born from the collapse of heavy elements, living on a dense rock orbiting a burning star. But this perspective is a hallucination born of our limited scale. The reality of the cosmos is not substance. It is absence. Right now, at this very second, the universe is being pulled apart. It is not being torn by explosions or violent collisions, but by the fabric of space itself stretching in every direction. The distance between galaxies is growing. The abyss between stars is widening. We exist in a cosmic sea where small islands of matter are drifting farther apart, destined never to reconnect. To understand the true nature of our reality, we must confront a statistic that defies human intuition. When astronomers conduct a census of the universe, measuring every star, every planet, every cloud of gas, and every stray atom, they find that ordinary matter accounts for less than 5% of everything that exists. Everything you have ever loved, every historical event, every mountain, every ocean, and every star burning in the night sky is part of that negligible fraction. The remaining 95% of reality is invisible, composed of forces and substances that do not interact with light, do not touch us, and yet dictate our fate. We call these components dark matter and dark energy, placeholders for a physics we barely understand. But before we face the force tearing us apart, we must understand the ghost that holds us together. Imagine taking the entire observable universe and compressing all its visible matter into a single ball. Compared to the vast volume of space it occupies, it would barely register. The average density of the universe is roughly 6 hydrogen atoms per cubic meter. In the empty space of the room you occupy, there are trillions of times more particles than in the same volume of deep space. The universe is not a place filled with things. It is a place made mostly of nothing. But this emptiness is not simple. It is not merely a lack of material. It is a dynamic, structural component of reality. Well, when astronomers in the 20th century began studying the rotation of spiral galaxies, they encountered a physical impossibility. According to the laws of Newtonian gravity and Einstein's relativity, stars at the edges of a galaxy should orbit slower than those near the dense center, but they don't. The outer stars move at breakneck speeds, velocities so high that they should be flung out into the void. Based on the visible matter alone, the stars and gas we can see, every galaxy in the universe should have torn itself apart billions of years ago. They should be dissolving sprays of light, not tight, cohesive spirals. Yet they remain intact. Something invisible is holding them together. We call this missing mass dark matter. It is a ghost substance. It does not emit light, it does not reflect radiation, and it casts no shadow. As it passes through ordinary matter as if it weren't there. Right now, trillions of dark matter particles are streaming through your body. They pass through the Earth, through the Sun, and through the core of the galaxy without slowing down. We only know they exist because of their gravity. Dark matter outweighs visible matter by a ratio of 1:1. It forms a massive, invisible halo around every galaxy, a gravitational scaffolding that traps gas and allows stars to be born. Without this invisible hand, the Milky Way would be nothing more than a thin, structureless fog. You would not exist. But if dark matter is the skeleton of the universe, emptiness is its flesh. When we map the cosmos on its largest scales, we do not see a random scattering of galaxies. We see a web, a vast, glowing neural network of matter stretching across billions of light years. In this cosmic web, Galaxies flow like liquid along thin filaments of dark matter, pooling in massive clusters where the threads intersect. But between these filaments lie the true giants of the cosmos, the cosmic voids. These are not merely gaps. They are abysses of a magnitude that the human mind struggles to comprehend. Some of these voids span hundreds of millions of light years in diameter. Inside them, galaxies are incredibly rare. The density of matter drops to near zero. If you were floating in the center of a large cosmic void, you would see nothing but absolute blackness. The nearest galaxies would be so distant that their light would not reach your eyes. You would be suspended in a perfect, silent isolation. As to cross one of these voids at the speed of light would take longer than complex life has existed on Earth. Light that began its journey across a void when the first multicellular organisms appeared in our oceans would still be traveling through the darkness today. These regions of nothingness dominate the volume of the universe. The bright, beautiful structures we see in telescope images, the nebula, the clusters, the spiral arms, are merely the thin walls of foam surrounding vast bubbles of near vacuum. And this is where the story turns from scientific to existential. These voids are not passive. They are growing. Gravity is the only force that can resist the expansion of the universe, pulling matter together. In the dense filaments and clusters, gravity is strong enough to win. It binds galaxies into groups, like our own local group. But inside the voids, there is almost no matter to generate gravity. In these empty regions, a different force takes over. Dark energy. Unlike dark matter, which pulls things together, dark energy pushes space apart. It seems to be a property of space itself, the cost of having nothing. Every cubic meter of empty space contains a tiny amount of this energy. But because space is so vast, the total amount of dark energy overwhelms everything else. It accounts for nearly 70% of the total energy budget of the cosmos. Inside the voids, dark energy operates unopposed. It stretches the vacuum, creating more space. As more space is created, more dark energy appears, which pushes harder, creating even more space. This creates a runaway effect. The voids are expanding faster than the universe as a whole. They are swelling bubbles of nothingness, crushing the filaments of matter between them, thinning the cosmic web. Matter is draining out of the voids, flowing toward the dense regions, while the empty spaces grow larger, colder, and more dominant. This is a one-way process. The universe is naturally evolving toward emptiness because emptiness strengthens the force that destroys structure. From our vantage point inside a galaxy, this war between gravity and dark energy feels distant. The stars look fixed. The ground feels solid. But if you zoom out far enough, the pattern is terrifyingly clear. Matter is retreating into isolated pockets. The universe is not slowly filling up. It is being hollowed out. We are living in a cosmic era that resembles an eroding landscape. The mountains of matter are crumbling, and then the ocean of emptiness is rising. This leads us to an uncomfortable realization about the architecture of our reality. We assume that space is just a stage where events happen, a passive backdrop for the drama of life and stars. But the science tells us that space is the antagonist. It is an active agent that seeks to separate. Dark matter built the house we live in, but dark energy is tearing the foundation apart, room by room. We are currently observing a temporary balance. We live in the brief window of time where the universe is still rich with structure, where the web is still connected. but the voids are winning. They are the engines of the future, vast factories of isolation that are pushing the galaxies away from one another. As we stare into the deep field images from the James Webb or Hubble telescopes, we are not just looking at history, we are looking at a structure that is unraveling. The emptiness is not just out there, it is the defining characteristic of our universe. We are anomalies, dense, hot, complex clumps of matter huddled together against a vacuum that is aggressively trying to space us out. And as we will see, this expansion does more than just move things around. It erases them. The growth of these voids is the first step in a process that will eventually strip the sky of its stars and silence the cosmos forever. The architecture of absence is being built, and we are trapped inside the walls. For most of human history, the universe was assumed to be eternal and unchanging. The stars were fixed points of light, the galaxies were permanent fixtures, and space itself was merely a passive stage where the drama of existence unfolded. That assumption was wrong. In the 20th century, humanity uncovered a truth that fundamentally altered our understanding of reality. The universe is not static. It is exploding. When astronomers first realized that galaxies were moving away from one another, the assumption was that this expansion would eventually slow down. Gravity, the great attractor, should be pulling on the brakes, gradually reigning in the cosmos. But in 1998, when researchers measured the light from distant supernovae, they found the opposite. The universe is not decelerating. It is accelerating. The expansion of space is speeding up. This acceleration introduces a terrifying concept into cosmology: the cosmic event horizon. We know that the speed of light is the absolute speed limit of the universe. Nothing can travel faster. However, space itself is not bound by this rule. Over sufficiently large distances, the cumulative expansion of space pushes galaxies apart at speeds that exceed the speed of light. This creates a boundary, a spherical wall surrounding us, beyond which events can never affect us, and from which light can never reach us. Right now, that horizon sits roughly 16 billion light-years away. Any galaxy that crosses this line is effectively deleted from our reality. It still exists. It still burns with the light of billions of stars. It may even harbor civilizations looking back in our direction. But it is causally disconnected from us forever. Its light, struggling against the stretching of space, will never close the gap. It is like a runner on a treadmill that is accelerating. No matter how fast the photon runs, the space beneath it expands faster. The unsettling truth is that the observable universe is shrinking, not in size, but in access. Every year, thousands of galaxies drift across this horizon and vanish from our future. The universe is actively erasing its own contents. We are losing information that can never be recovered. This process is invisible to the naked eye, because the light we see today left those galaxies billions of years ago, when they were still within reach. We are looking at ghosts. But the reality is that the present-day versions of those galaxies are already gone, carried away by a current we cannot fight. This leads to a profound realization about our place in history. We live in a privileged era. We exist at a time when the universe is still crowded enough to be understood. But this window is closing. In the distant future, perhaps 100 billion years from now, every galaxy outside our own gravitationally bound cluster will have crossed the horizon. They will fade into the red infrared darkness and then disappear completely. Future astronomers born in that era will look out into the night sky and see nothing but their own galaxy and a few dying neighbors. They will see no evidence of the Big Bang, no cosmic background radiation, and no other galaxies. They will conclude, based on all available evidence, that the universe is static, small, and lonely. They will build models of physics that are completely wrong because the evidence required to know the truth will have been exiled beyond the horizon. We are the only ones who will ever know that the universe was once vast. But this isolation is not just a future threat. It may explain a mystery that haunts us right now. The universe is nearly 14 billion years old. There are hundreds of billions of stars in the Milky Way alone and trillions of galaxies in the observable cosmos. The raw ingredients for life, carbon, water, energy, are everywhere. By all statistical probability, the universe should be teeming with intelligence. We should be detecting signals, seeing megastructures, or finding evidence of galactic colonization. Instead, we find silence. This is the Fermi Paradox. Where is everybody? We have scanned the radio waves for decades. We have looked for the heat signatures of Dyson spheres. We have analyzed the atmospheres of distant exoplanets. We have found nothing. The silence is so absolute that it feels heavy. There are many theories to explain this. Perhaps life is incredibly rare. Perhaps civilizations destroy themselves with nuclear fire or biological engineering before they can leave their home planets. But there is a darker possibility, one that ties directly to the expansion of the universe. Perhaps civilizations are not rare. Perhaps they are simply unreachable. The universe imposes a brutal constraint on contact, time, and distance. For two civilizations to meet or even exchange signals, they must exist not only in the same galaxy, but in the same narrow slice of time, close enough that the signal doesn't take millions of years to arrive. But space is stretching. The gaps between civilizations are widening. If a civilization arises in a distant galaxy and sends a signal toward us, that signal must traverse the intergalactic void. As it travels, space expands, stretching the wave, stealing its energy, and redshifting it into noise. We may be living in a universe filled with voices that can never reach one another. The expansion of space acts as a cosmic sensor, ensuring that intelligent species remain isolated. It is possible that civilizations rise and fall constantly, scattered like islands in a vast ocean. But the ocean is expanding faster than they can build ships. We are not alone in existence, but we are alone in experience. This reframes the emptiness of the night sky. It is not necessarily a sign of absence. It is a sign of disconnection. The universe does not favor community. It favors isolation. The physics of dark energy ensures that everything eventually drifts apart. The great tragedy of the cosmos may be that it allows consciousness to emerge, allows it to look up and wonder, but denies it the ability to ever find a kindred spirit. We are listening to a universe full of missed connections. A signal sent from the other side of the Milky Way takes 100,000 years to reach us. If human civilization has only been capable of receiving signals for less than a century, the window of overlap is vanishingly small. We are screaming into a void that is actively running away from us. And this isolation is accelerating. As dark energy strengthens its grip, the clusters of galaxies will be pulled apart. The local groups will tighten, but the highways between them will dissolve. The universe is fragmenting into pockets of reality that will never interact again. This is the great disconnect. It is the mechanism by which the universe slowly shuts down the possibility of a shared history. The horror of the Fermi Paradox is not that we are the only ones here. It is that we are trapped in a prison of geometry. The walls of this prison are moving outwards at the speed of light, and every day, more of the universe falls behind them. We are drifting in a sea where the other islands are not just far away. They are falling off the edge of the world. This changes the nature of our loneliness. It transforms it from a biological accident into a cosmological mandate. We are alone because the universe is structured to keep us that way. The silence we hear is the sound of space expanding, putting distance between all things, ensuring that every civilization is the protagonist of a story that no one else will ever read. The darkness is not empty, it is simply too fast. And as we will see, this accelerating isolation is only the precursor to a much longer, colder, and more final silence. The universe has not yet finished dying. It has only just begun to freeze. The universe does not end with a bang. It does not collapse in fire or tear itself apart in a sudden cataclysm. It ends in silence. It ends with a long, slow exhale that lasts for eternity. We are currently living in the stelliferous era, the age of stars. It is the only time in cosmic history when the universe will be bright, warm, and capable of supporting complex life. But this era is temporary. It is a brief flash of light in an infinite timeline of darkness. Right now, stars are burning everywhere. Nuclear fusion is converting hydrogen into helium and releasing the energy that powers the cosmos. But stars are machines with finite fuel. Every second they burn, they consume resources that can never be replaced. Astronomers studying the history of the universe have discovered a sobering trend. Star formation peaked billions of years ago. The universe was once far brighter, far more violent, and far more productive than it is today. Back then, galaxies collided frequently, compressing gas clouds and igniting waves of new suns. Now, expansion has spread the galaxies apart. Collisions are rarer. The gas clouds are growing thinner. The universe is already past its prime. In roughly 1 trillion years, star formation will effectively cease. The raw hydrogen needed to ignite new stars will be locked away in dead remnants or scattered too thin to ever collapse again. And no new suns will be born anywhere. The nursery is closed. But the darkness does not arrive all at once. It creeps in. The massive blue stars die first, exploding as supernovae and vanishing quickly. The sun-like stars follow, swelling into red giants before shedding their layers and shrinking into white dwarfs. The last survivors will be the red dwarfs, small, efficient stars that burn their fuel so slowly they can shine for trillions of years. They will be the final campfires in a cooling world. But eventually, even they will falter. One by one, they will exhaust their hydrogen, flicker, and fade. When the last star dies, the universe enters the degenerate era. Galaxies will no longer be islands of light. They will be graveyards of stellar corpses, white dwarfs, neutron stars, and black holes drifting through the dark. The temperature of the universe will continue to drop. Space will continue to expand. Energy will spread thinner and thinner. This is not emptiness yet. It is exhaustion. Over unimaginable spans of time, even the remnants will degrade. White dwarfs will cool toward absolute zero, becoming black dwarfs. Objects so cold and dark they are effectively invisible. Dense balls of crystallized carbon floating in the void. Neutron stars will spin down and go silent. Interactions between objects will become statistically impossible. In this era, if 2 dead stars collide, it will be a rare and spectacular event, a momentary flash in a universe that has been dark for eons. But mostly, nothing will happen. Time will pass, but there will be no one to measure it, and nothing to mark its passage. Then, the final stage begins. The black hole era. And eventually, the only organized structures left in the universe will be black holes. They will sweep up the remaining matter, dominating the cosmos. For a long time, physicists believed black holes were eternal. But quantum mechanics reveals a cruel twist. Through a process known as Hawking radiation, black holes leak energy, particle by particle, over timescales that defy human comprehension. They evaporate. A supermassive black hole might take a Google years to vanish. That is a 1 followed by 100 zeros. But in the face of eternity, even a Google years is a heartbeat. As they die, they will release their mass back into the universe as a faint bath of radiation. When the last black hole evaporates, flashing out of existence in a final burst of gamma rays, the universe crosses the ultimate threshold. This is heat death. The second law of thermodynamics states that entropy always increases. Energy spreads out. Differences smooth over. Systems move toward equilibrium. Heat. Death is not a dramatic event. It is the final balance sheet. At this stage, the universe has reached maximum entropy. There are no temperature differences left to exploit. There are no energy gradients to drive motion, chemistry, or thought. The universe becomes a uniform sea of subatomic particles and low-energy photons, drifting through a vacuum that is expanding exponentially. Time still passes, but it has lost its meaning. Time is measured by change, by the ticking of a clock, the orbit of a planet, the decay of an atom. When nothing changes, time becomes an empty coordinate. The universe effectively becomes timeless, frozen in a state of eternal suspension. This is the long victory of emptiness. It is not violent, it is absolute. The universe is not empty by accident. Its emptiness follows directly from its laws. The same expansion that cooled the early universe enough for atoms to form eventually cools it too much for anything to survive. The same gravity that pulled galaxies together eventually loses the war against dark energy. From this perspective, our existence is not miraculous. It is conditional. We exist because the universe is passing through a specific, fleeting configuration where density, temperature, and time are perfectly aligned. That configuration is already dissolving. Every second, space expands. Every billion years, fewer regions remain connected. Every process that relies on interaction becomes harder to sustain. This realization reframes the concept of the void. It is not just a spatial separation between galaxies. It is the end state of reality. The void is what remains when the energy runs out. It is the baseline to which everything returns. And yet, there is a final, terrifying postscript to this story. In an eternal, empty universe, quantum mechanics refuses to let absolute nothingness exist. Even in a perfect vacuum, energy fluctuates. Particles briefly pop into existence and vanish. These fluctuations are usually meaningless. But given infinite time, the impossible becomes inevitable. In the far, far future, long after the stars are gone and the black holes have faded, random quantum fluctuations could, in theory, assemble matter into organized structures. Most of these would be chaotic blobs of particles. But if you wait long enough, eternities upon eternities, a fluctuation could randomly assemble a brain. A fully formed, conscious mind, complete with memories of a life it never lived, thoughts of a world that doesn't exist, and a sensation of now. Physicists call these Boltzmann brains. These lonely, hallucinating minds would appear in the void, exist for a microsecond of confusion, and then dissolve back into the chaos. It is a disturbing thought. In a universe that lasts forever, there may be more of these random, fleeting consciousnesses than there ever were real biological minds. The final observers of the cosmos might not be explorers or scientists, but tragic accidents of quantum probability, flickering in the dark, dreaming of a universe that died trillions of years ago. This is why emptiness matters. It is the canvas, the paint, and the eraser. It is the beginning and the end. We look out at the night sky and see the stars as the main characters, but they are just the sparks from a dying fire. The darkness is the true protagonist. But do not let this terrify you. Let it awaken you. The fact that we are here, right now, in the brief stelliferous era, is a statistical triumph. We are the universe's way of experiencing itself before the lights go out. We are the eyes of the cosmos, open for a split second in the middle of a long slumber. The emptiness is coming. The silence is inevitable. But for now, we are loud. We are bright. We are together. The universe may be biased toward separation, but we are the resistance. Every time we look up, every time we speak, every time we connect across the distance, we are defying the geometry of the void. Oh, we are the rare, precious anomalies in a universe of nothing. So look around you. Look at the people you love, the world you live in, the stars above your head. Do not take the solidity for granted. It is a temporary gift. The void is waiting, but it hasn't won yet. If you enjoyed this journey through the emptiness, hit the like button and subscribe. It helps us keep the lights on a little longer. Thanks for watching.